video for the course, which is the Module 7 Matrices Restructured. So I'm going to be honest, I did definitely struggle with this module just because it's been so long since I've done it, and it probably has the most steps out of everything we've covered. So I did my very best on this problem. I tried to use lecture notes to get the procedure correct. So hopefully this is as close as I can get to hopefully doing this right. But I really tried to look at the process, and I figured even if I made maybe one or two little errors in here, I think I got the process for the most part down. So I really kind of try to take it one step at a time. So I have my original right here. I pasted in the problem. I actually thought this was really interesting, and I didn't enjoy matrices to begin with, but I actually had a little bit of fun with this challenge, even if I didn't do it perfectly. So my original problem here, the matrices, I have x, y, z, w are the variables in the final matrix that I want to solve for. So I took this original matrix here and I basically rewrote it out. But what I want to do is subtract the 2x2 matrix right here, 2, 4, 1, 7, from each side. So I'm finding the inverse essentially of this matrix in order to originally I probably would have said cancel out before taking this class. However, I'm making it a zero pair. So right here I have the 2, 4, 1, 7. I have -2, -4, -1, -7. And I'm going to add that matrix to each side. So now I'm going to have the original left side, minus this matrix. And now I have 0, -4, 2, and 11 here. So this is my next step. Now I just have to find the inverse of each side to make a one pair here. So my x, y, z, and w are isolated in order to find out what x, y, z, and w equal. So I found my inverse. Up here, I did a little side work to find the inverse. So I had to find the determinant, which was AD minus BC. It ended up coming out to 1. So 1 over 1, so this is 1 over the determinant. Ended up really just coming out, the inverse was this matrix here. So -1, -3, 1, 2, or if I set it across that way. So here, right here is my inverse. I circled it in blue here. Now I'm going to multiply each side by that inverse. So I want to make the one pair over here, where I have it in green, the inverse. Now I just have the x, y, z, w alone. And I showed what happened when I multiplied these two matrices. That took me quite a few steps just to, a few checks of myself to make sure I was doing it correctly. So I kind of had, little intersections of the two parts, and I'm not going to go through that totally, but this is right here is where I ended up adding the two parts of each item. And then I basically came out to this blue circle at the very end, 12, -8, -35, and 24 is my final XYZW matrix. So I want to mention a couple of things in here, just some properties. I wanted to highlight the commutative property here. So each side, it was really a lot easier in this situation to put the multiplication, the green ones right here, on this one was on the left. So before the original matrix, this one was on the right. So really with multiplication here, actually, I'm remembering now that the properties of multiplication are not commutative. So I'm realizing I probably should have. I just want to make sure I did this right. I'm gonna just actually refer back to the. I'm gonna go right back here. Sorry. So I'm going to just go along with what I have for now, and I'll write my additional notes in the comments. Because what I did was I multiplied by the inverse here on each side, and then I ended up coming out with this final answer. I found this really interesting, really almost kind of fun to do. But I'm going to pause right here and put any remaining comments in the comment section. Thank you so much for following with me during this course and these videos, and that's it.